If you observe, the solubility of benzoic acid in water is 2.3 grams for every 100 grams of water. However, after the deprotonation, the solubility of this benzoic anion increases dramatically and it reaches almost 63 grams for every 100 grams of water. So because of the bulk in this benzoic acid, the solubility is low. Whereas because of the change in polarity and the charged species, the solubility in water increases. The next part of the separation that you need to understand is that pKa values, when they are smaller in number, we say that the acid is stronger, whereas a large pKa value indicates a weak acid. For you to determine if a reaction will go in the forward direction or not, you always have to remember that your starting acid needs to be a strong acid, whereas your generating acid should be a weak acid. Only then this reaction will go in the forward direction or will show any products or is known to be a favorable reaction. How do we decide to separate out two molecules based on two different bases? If you look at the pKa values of these given acids, we will see that the benzoic acid's pKa value is 4.17, whereas the 2-naphthal's pKa value is 9.5. By keeping that in mind, we will see that when the benzoic acid is reacted with sodium hydroxide and the corresponding anion is formed, the resulting acid that we get in this reaction, the conjugate acid, the starting acid, we see that the starting acid has a lower pKa, hence stronger, whereas the resulting acid has a higher pKa and hence weaker, which conforms to this topic or this concept that you need to have a stronger acid in your products and a weaker acid in your products. So a stronger acid in your starting materials and a weaker acid in your products. On the other hand, if we reacted benzoic acid with a little weaker base as compared to sodium hydroxide, sodium bicarbonate is a little weaker in strength as compared to sodium hydroxide as a base. By reacting this, the base will still abstract the proton, your anion will still be generated, but now you get a different kind of acid. But paying attention to the pKa values, we still observe that the resulting molecule's pKa value is higher, which means it is a weaker acid, whereas the pK value of the starting acid is lower, which means it is stronger. And hence, this reaction will also go in the forward direction. Similarly, with 2-naphthol, when you react with sodium hydroxide, the proton is deprotonated and we generate the corresponding anion, and we compare the generating acid, we see that the water, which is the conjugate acid, has a higher pKa value and hence less strong or less strength acid device compared to the starting acid, which has a lower pKa and hence a stronger acid. But when we write on paper the reaction of 2-naphthol and sodium bicarbonate to generate the corresponding anion and the conjugate acid from this particular reaction, we see that the pKa value of the resulting acid is lower, which means this is a stronger acid as compared to your starting acid. Even though I wrote this on paper, this reaction will hence be not possible. So looking back, sodium hydroxide will react with both, but sodium bicarbonate will only react with one of them. And this is the base which will help us achieve selective separation of the molecules. So once you have your MTBE mixture in which you have aqueous solution added, we will add sodium bicarbonate first to selectively react the sodium bicarbonate with benzoic acid and not with 2-naphthol. So only the benzoic acid will be converted into its corresponding anion and it will then migrate to the aqueous layer. Once it migrates there, you can drain out and collect it in beaker 1. Similarly, in this leftover MTBE mixture, we will now add sodium hydroxide. Now, sodium hydroxide will definitely react with the 2-naphthol and any leftover benzoic acid also. However, you need to remember that the second extraction is only for 2-naphthol, not for your benzoic acid. The first extraction was for the benzoic acid. The second extraction with sodium hydroxide is for 2-naphthol majorly. You will see formation of bubbles in this particular system.